So today I'm going to verify this identity, and verifying an identity is the same as proving that the identity is true. And remember that when we're dealing with identities, we don't want to cross from one side of the identity to the other side. So we're just going to work on one side. And the side that we pick is usually a more complicated side. So in this particular problem, I think that the left side is more complicated. And the first thing I'm going to need to be able to combine these two fractions is to find an LCD, a lowest common denominator. And my lowest common denominator is going to be each of these denominators. So 1 minus sine x times 1 plus sine x. So I'm going to need to make this first fraction into a fraction where my denominator is 1 minus sine x and 1 plus sine x. So I'm going to find an equivalent fraction. So what did I do to this denominator to get me to this denominator? Well, I multiplied it by 1 plus sine x. So that's what I need to do in the numerator. I need to multiply the numerator by 1 plus sine x. And we're going to do the same thing with the second fraction. Again, what do we need to do to the denominator to get the LCD that we have? We needed to multiply by 1 minus sine x. So that's what we're going to do in the numerator. Multiply it by 1 minus sine x. Now that we have a common denominator, we can combine our numerators. So the first numerator is going to be 1 plus sine x over this LCD minus my second numerator is 1 minus sine x over the same LCD. Now that I have the same LCD, I'm going to combine my numerators. But be careful when you combine. This second numerator, the entire numerator is being subtracted. So we want to make sure that when we subtract, that we subtract the entire expression. And now I can rewrite it as all over that LCD. Simplifying a little bit further now, I'm going to carry the negative through the parentheses, so I end up with 1 plus sine x minus 1 plus sine x all over this denominator. And when I multiply this out and FOIL it, I end up with 1 minus sine squared x. And that's going to become important later on. So in the numerator, my 1's cancel out, and I'm left over with 2 sine x over 1 minus sine squared x. Now remember what our goal is, if we look up top here, our goal is to end up with a tangent and a secant. So maybe it would be helpful to rewrite these in terms of sine and cosine. So remember that tangent can be rewritten as sine x over cosine x, and secant can be rewritten as 1 over cosine x. So if I combine all that together, I could rewrite this as 2 sine x over cosine squared x. So now looking down at what we have, can I get this to match what I have up here? And we should remember that 1 minus sine squared x is one of our Pythagorean identities, and it's equal to cosine squared x. So substituting that in, I end up with 2 sine x over cosine squared x. And notice that this is the same as what I got up here. So I have verified the identity. Our second identity that we're looking at today is this one right here. And here the more complicated side is the right side. And I think the best technique for this would be to rewrite all this in terms of sines and cosines, because that's what we're most familiar with. So that's what I'm going to do first. I'm going to rewrite cotangent as cosine x over sine x, and I'm going to rewrite tangent as sine x over cosine x. That's in my numerator of this fraction. And then in the denominator, I'm going to rewrite cosecant x as 1 over sine x. Then I'm going to try to simplify this complex fraction. So looking at this complex fraction here, I'm going to look at all my denominators and figure out what the LCD is for the entire complex fraction. So my LCD is going to be sine times cosine and in the denominator I have sine again to the first degree. So my LCD is going to be sine x times cosine x. And I'm going to multiply my numerator by that and my denominator by sine x cosine x. When I do that, on the left I still have secant x sitting there. On the right, I'm going to have sine x cosine x times this. Plus sine x cosine x. So I'm just using my distributive property and multiplying it through each one of my terms in the numerator. And then I'm going to do the same thing in the denominator. And what this does is it gets rid of all these fractions that I had to look at. So now I can simplify this entire expression into cosine squared x plus sine squared x all over cosine x. And remember, one of our Pythagorean identities says that cosine squared x plus sine squared x equals 1. So substituting that in, I end up with secant x equals 1 over cosine x. And then I know that 1 over cosine x is secant x. So we have verified this identity. In this identity, we want to again combine our fractions, and to combine the fractions we need to find an LCD. My LCD is going to be what I have in my denominators here, so 1 minus cosine x times 1 plus cosine x. So going ahead and making equivalent fractions for each of these fractions, I'm going to rewrite 1 over cosine x, 1 over 1 minus cosine x, with a new equivalent fraction where this is my denominator. So what did I have to do to this denominator to get to the new one? I had to multiply it by 1 plus cosine x. And then I'm going to do the same thing with my second fraction. So I started off with cosine x over 1 plus cosine x. And I want to make it into a new fraction where this is my denominator. And what did I do to this denominator to get over here? Well, I multiplied it by 1 minus cosine x. So I'm going to take what I already have in the numerator and multiply it by 1 minus cosine x. So now that I have the same denominator for my equivalent fractions, I can go ahead and subtract them. So I'm going to have 1 plus cosine x, and I'm going to be subtracting the second fraction, cosine x times 1 minus cosine x. And then that's going to be all over my LCD. 1 minus cosine x times 1 plus cosine x. Using my distributive property in the numerator, I end up with 1 plus cosine x minus cosine x plus cosine squared x. In the denominator, when I FOIL this, I end up with 1 minus cosine squared x. Now at this point, I want to look at what I'm looking for. What am I trying to my goal is? Well, my goal is to get to 2 cosecant squared x minus 1. And all I have down here are cosines. So let's talk about what cosecant squared x is going to look like. So we want it to be equal to cosecant squared x minus 1. Well, remember, cosecant squared, or cosecant rather, cosecant x is equal to 1 over sine x. So if I have cosecant squared, it's going to be 2 over sine squared x minus 1. So somehow I have to get a sine squared down the bottom. Well, looking at my denominator here, I have a Pythagorean identity. 1 minus cosine squared x is equal to sine squared x. I'm going to use that identity right here. At the same time, I'm going to simplify and cross out my cosines in the numerator. So I end up with 1 plus cosine squared x over sine squared x. Notice in the denominator I have a common factor of, or I only have one denominator here. And over here my fractions are not combined. So I'm going to combine them by making 1 into an equivalent fraction where sine squared is in my denominator. So 2 over sine squared x stays the same, and I'm going to subtract sine squared x over sine squared x. So now I end up with 2 minus sine squared x over sine squared x. Somehow I have to get this cosine squared into sine squared. And we need to remember that cosine squared x, from our Pythagorean identity, is equal to 1 minus sine squared x. So I'm just going to substitute this in for cosine squared. So now I have 1 plus 1 minus sine squared x over sine squared x. Combining my numerator, I end up with 2 minus sine squared x over sine squared x. And that's the same as I had up here, 2 minus sine squared x over sine squared x.